someone. So if you mute, it will be very convenient to all the participants. Okay, now I will start my first session. Give me some time to share my presentation. You are able to see my screen? Somebody please respond.
Yes, sir.
Sir, we are able to see your screen, sir. Go ahead,
Yeah,
sir.
great. So I will start with, okay, fine. So I will start with this session where I will present a brief overview of how municipal solid waste management is being handled today in the country or even in the other countries. Maybe that becomes a basis for why we have to look at composting technologies for a better municipal solid waste management. Of course, composting is possible even for agricultural waste management, but that is very traditional. That is being practiced easily than what it is being done in municipal solid waste management. The only reason why composting in agricultural waste management is much more easy is there you get homogeneous waste from the agricultural practice, whereas in municipal solid waste you get all kinds of materials. Maybe as most of you must be seeing, whatever you find dustbin that comes as municipal solid waste. So you have so many items that are there. If you start observing what will be there in a dustbin, you can at least figure out at least 10 items. So all these 10 items, 10 different items which behave differently, those pose problems for composting. So with this thing, so what is solid waste? Solid waste are simply, I think there are some people from other discipline. So for them not to confuse with other waste, I am going from very basics, but I will quickly go through the basics. So waste that you find in dustbin. So you must be having a dustbin in your house. You will be seeing a dustbin on the road. Whatever you find in the dustbin is solid waste. You can uh, you can accept it as a layman's definition. But if you go for engineering, that means if you really want to define it in the engineering sense, waste which cannot be transported along with water are solid waste. So there is always problem with confusing fecal matter with solid waste. So that is the reason why they have defined waste which cannot be transported along with water or which cannot be flushed out in the toilet are called as solid waste. But when you go for legal or regulatory aspects, these two terms will not be holding good. So that is the reason why you get the third definition, which is accepted legally. The solid waste legally for regulation purpose is defined as heterogeneous mass of throwaways. Heterogeneous means different kinds of material from residential and commercial. That means in a municipality, you will have residential activities, commercial activities like hotels, markets, hospitals, shops, all these kind of things, as well as the more homogeneous accumulations of single industrial activity. So in addition to shops and commercial activities that you have industry also. So from industry, most of the time you get homogeneous accumulation. Say like you go to a textile industry, you get most of the material that you get is the rags or cut pieces that are wasted, or cotton that is wasted. So that maybe you go to a tannery, you get pieces of leather or pieces of skin, this kind of thing. So for that reason, they have included industry as well, by saying the more homogeneous accumulations of single industrial activity. So all the waste that come from your house, shops, markets, shopping complexes, all these plus the waste that come from industrial activity are termed as solid waste, right? Now, what is the problem? So why are we talking about solid waste? Because we have been living on the planet since several years, since several decades, since several centuries. So now if you really look at the solid waste problem that we have, you find countless materials. Countless materials. That's what. Yeah, even little earlier I was trying to tell you. You go and see a dustbin. What do you find? You find paper, you find food waste, vegetable waste, you find plastic, you find thermocol, you find leather, you find glass, you find metal, all kinds of things, at least 10 to 12 items that are found in the dustbin. So for this reason, in the modern society, as you go on using more and more materials, the dustbin is flushed with more and more different kinds of waste that come into the dustbin. And more so, the additional aspect, why we talk about, that is about variety, diversity of waste. The second thing is the quantity of waste. The tradition and practice today is only throwaway. That means you go anywhere today, you find a throwaway society. You find a throwaway cup, throwaway napkin, throwaway kerchief, throwaway plate, disposable pen, disposable, all kinds of disposable. The order of the day is disposable. Say for example, you take a pen. You take a pen. What do you do today? You use it and throw it. But go 20 years back or 30 years back, what people used to do, if they had a pen, they had one pen, they used to fill ink and they used to use it again and again. But now today, you don't do that. Maybe during this transition, what happened was, you had a pen, you used to use, instead of filling ink, you used to replace the refill. But today, the refill concept is also almost gone. You use a pen and throw it. Now, if you really look at the functional aspect of a pen, the functional aspect of a pen is 10% of the quantity of the material that is used for making the pen. So what happens? So instead of throwing the 10% away, or when you are using, you are not even throwing away, what you are throwing today? You are throwing the 100%, which means you are adding to waste quantities. You are adding to waste quantity. So the waste quantity that is generated today in urban areas is around 0.5 kgs per capita per day in India. It ranges from 0.3 to 0.5. But there are several countries which produce 2.5 to 3.5 kgs per capita per day. And maybe we will also be going there. So when you do that, it becomes very difficult to handle the waste. Already we are facing problems with managing waste with this 0.3, 0.5 kgs per capita per day. If it goes by to 2.5 kgs per capita per day, our problem will be 5 times or 6 times of what we have. So that is the reason why we have to talk about alternative methodologies or alternative practices or sustainable practices for handling waste. So this throwaway society leads to violation of ecological principle that all materials are recycled. So all materials can be recycled, but at what cost? At what rate? So if you are recycled material, see, generally you say plastics can be recycled, paper can be recycled, many things can be recycled, but all have a limitation. So you are going against the ecological principle of saying that all materials can be recycled. Then the common sense dictates, simple common sense that you are having dictates that the throwaway society is not sustainable. That means if you go on producing more and more waste, tomorrow you will not be left out with any space for living. So that is why you say it is not a sustainable society. And if you look at all these, what we say is we are at the brink of the crisis. If not crisis, we are at the threshold of the crisis. And we are running out of places to dispose it. Maybe many of you must have seen, even in Delhi, they used to dump waste in one particular area, one particular distance, but that space is no more available. They are forced to go much far away to dispose of waste. The same thing is happening even in cities, villages, towns, and other things. So that is the reason why we have to immediately think about sustainable practices. So that is there is the problem. So what are the general terms that we use in municipal solid waste? So basically, refuse and solid waste are used as synonyms. Maybe refuse was the term which we used earlier. Refuse. That means useless material you refuse. And solid waste is the term that is latest one, which you say is the alternative term to refuse. So what is refuse or solid waste? Consists of all putrescible, that means that material which can undergo decomposition, and non-putrescible, that means that material which does not undergo decomposition, except body waste, except waste from body. That's what I told you. Fecal matter is not included into the refuse or solid waste. Then coming to the other things, garbage. Garbage is a component of solid waste, which is mostly from the kitchen, food waste and cooking waste, which during your cooking, you pre-process vegetables. During that, you create lot of waste that will go as waste, plus the food waste. That means the wasted food that you get. Then rubbish, the other component of solid waste, other than food waste, is combustible and non-combustible part. That means paper, plastic, metal, glass, all this is called as rubbish. Then coming to trash, trash is combustible rubbish. That means paper, plastic, these materials which can burn are termed as combustible rubbish, right? Then what are different types of municipal solid waste? You have municipal waste, which is mostly from residential and commercial. And today, industrial waste is not included in municipal waste because Government of India and several other governments across the globe, they said industrial waste have to be dealt by the industry on its own. Municipality is not responsible for dealing with waste from industry. So industrial waste, that means the homogeneous materials that come from single industrial activity, that is the one. Then you have the hazardous waste. There are some wastes which are hazardous, like hospital waste, radioactive waste. So these are some examples of hazardous waste. That means which are very, very dangerous. In what way they are dangerous? Hazardous waste essentially have these properties in combination or in isolation. So what are the properties which make waste as hazardous? Waste which can ignite or burn, that is what is hazardous. Waste which are highly corrosive. Waste which are highly corrosive. That means chemically they create action like acids. Then wastes which are highly reactive. Just now I told you, radioactive waste. Then chemical waste, which are highly reactive. Then the last one, waste which are toxic, poisonous, which can be dangerous for humans or for other living organisms. So any waste that possesses either one of these property or combination of these properties as is termed as hazardous waste. Fortunately, in municipalities, except the waste from hospitals, which is termed as biomedical waste, no other waste is hazardous unless there are industries which unauthorizedly throw away their waste into the dustbin with these properties. So in general, in municipalities, other than biomedical waste, no other waste is hazardous, right? Then coming to composition. What is this waste? What physically, what components are there in this waste? Composition is physical composition of solid waste is represented in four parameters, through four parameters. First one is individual component. Next one is what is the particle size. The next one is moisture content and what is the density. These are four properties which describe what is the composition, physical composition of solid waste. Right? Now, when you look at the physical composition, you see what is the waste comprising of. I told you garbage. In the residential sector, you have rubbish. I told you paper, glass, plastics, metal, etc. Then ashes, fire residue. Of course, this one with the use of LPG, you are no more using wood or coal, so you don't have ashes, but still ashes can be a component of solid waste. All these three items, they come from houses, hotels, shops, markets, which means they essentially come from residential activity. Then street refuse, that means on the road, it is also part of urban area. So what you get is sweepings, dirt, leaves, etc. So whenever you clean the road, you get sweepings, mostly soil and other materials. Then you get some dirt. Then you get some dirt. Then you get some leaves, flowers, this kind of things which are thrown on the road. And if you are not very conscious citizen, you throw paper cups, you throw plastic, you throw anything and everything on the road. All these will be present in street refuse. But in many countries, you don't find all those. If you litter on the road, you will be fined. I think you know what I mean by littering on the road. You throw any material by yourself on the road instead of dustbin, then you will be fined. Even the small country like Singapore, if you throw a chocolate paper, if people catch you, you are supposed to pay a fine of 500 Singapore dollars. So you are forced to be conscious. If you are not conscious, you are forced to be conscious legally. Then dead animals, maybe sometimes you have birds which die. You have some other animals like rats or dogs or some animals which die, which are there on the road. Then you have abandoned vehicles. You have abandoned vehicles. 1 second. Somebody is asking me how to enter. No. Okay, anyhow. Then abandoned vehicles. That means you have some vehicles which are left on the road. Maybe for various reasons, they are of no more use. Maybe some cycles, some auto rickshaw, some cycle rickshaws, even sometimes cars, sometimes spare parts of these which are no more used. They are also there, mostly metal. They are also from the municipal area, that means residential, commercial, this kind of things. These are sources are roads, garages, sidewalks, vacant areas. You find these materials. Then the biomedical waste, I told you, medicines, which are uh, either expired or unused or spilled or whatever. Then disposables. That means today you find all kinds of disposables. Disposable syringe, disposable sachets, disposable bottles, all these things. That's the thing. Then amputated body parts. That means you get hurt, they remove skin, they remove hair. These kind of things are also there in biomedical waste. So all these are again where you find them in hospitals, clinics, and R&D units, which are linked with the things. So these are general sources and different kinds of materials that you find. But now, if you really look at the behavior of these materials, you see what is the behavior of these materials and why we are really interested in dealing with these materials. Say, first thing, you find lot of organic waste such as vegetable and fruit peel waste, leftover foodstuff, leaves and all that. And in India, at least 40 to 50% of the solid waste that you generate, that means out of 0.5 kgs that I was referring to, 0.25 kgs or 0.2 kgs is only organic waste such as vegetables peel waste or fruit peel waste, leftover foodstuff, leaves from the street and all these. So what is the time for them to decompose or degenerate into different material? Generally 7 to 15 days. 7 to 15 days. Whereas if you go to paper, paper is significant component that you find in the dustbin. It is 10 to 30 days. 10 to 30 days, which is slightly larger than the food waste. Then cotton cloth which you throw away from the what you call maybe used cloth or some torn away cloth or whatever, that is 2 to 5 months. 2 to 5 months. I request one of the participants, Dr. J. Javasti, please mute your video. And you are not, I mean, if you are listening to lecture, you have to have some discipline. Dr. Jabastin. See, this was a workshop which was intended for interested participants. See, if you are interested, you can log in, be available. If you are not interested, nobody forces you to log in. So if you are busy attending to something, please don't distract myself or the person presenting and the participants. See, all of you are matured individuals and I expect some discipline. Dr. Jabastin. Dr. Jabastin. I don't know, people are not following instructions. Okay, then you find some amount of wood Of course, these days, these wooden items have been reduced because we are no more using firewood. So wood items, if you find even small quantities, what is the amount of time that it takes for decomposition? 10 to 15 years. 10 to 15 years. That means it is easily not trackable. So that is why you don't want to have wood in your, then wool items. Again, wool items, because our country being tropical country, we use woolen clothes only in winter, very sparingly. So that is the reason why we don't find wool items in the dustbin frequently. But still, wool items, if you find, they take 1 year for decomposition. 1 year, which is again very huge period. Then metals, you find again today it is fancy to have soft drinks in cans, and you have some eatables in tins, you have some processed food in tins, and you after use you throw away. Generally these materials are tin, aluminum and other metal items are which are used for canning, and other metal items like iron, aluminum, which are used in other kind of activities. They take 100 to 500 years, more than your lifespan, or simply 1.5 times your lifespan, if not more. And just imagine from tomorrow you should think twice to throw away these materials. Even the rag picker gives you 10 rupees, you give it to him rather than throwing it to dustbin and creating a problem for 100 to 500 years. Then plastic bags. So that's why Government of India and several other governments across the globe, they are concerned about plastic pollution. Plastic bag or any plastic material for decomposition, it takes 1 million years, 10 power 6, few generations later, few centuries later. That's why people caution you everywhere, don't throw plastic, don't misuse plastic. Then glass bottles, glass, your soft drinks, your what you call cool drinks, your what you call all kinds of drinks that you get, soda, dairy milk, all these, undetermined. That means the time taken for decomposition of glass is undetermined. That means literally it is not possible. So it is not fancy or not advisable to throw away glass or to break glass. Right? So next one. Okay. Now to take you to some base, some onto the ground. That means, say in Warangal, we have taken up some study where we have found out what are different materials that are found in the municipal solid waste of Warangal. Organic matter, 46%. Soil, that means sand, street sweepings and all that, 36%. And literally speaking, if you separate organic matter and soil, 82% gone. Your problem is only 28%. Soil can be easily disposed, no problem, if it is separate. Organic matter can be easily handled. That's what we will be talking about today, which organic matter is supposed to go to composting. That is 46%, which also poses no problem if it is separated, if it is segregated, if it is present in isolation. Unfortunately, what happens is it is not present in isolation. Participants are calling me. Hello? Yes? Yeah. FDP के लिए, if you have any issues, you call my research scholar. I am in the session. Okay. I gave instructions that You should not call me. Okay. So 46% gone, 36% gone. Unfortunately, what happens is this organic matter is mixed with everything and anything that you find when you find it in the dustbin. That is why we are having problems. That is why we are having problems. Then paper, of course, in India again, we are little disciplined in that matter. That means you don't throw away paper. You save the paper. You keep the paper aside and you give it to the scrap buyer. Maybe he gives 10 rupees per kg or 12 rupees per kg, but you are disciplined, you give it to him. In several countries, the paper is left on the road for municipality to collect. But of course, you have to leave the paper in a separate dustbin. If you mix it, they will never take it. Then plastics, 3%. You find plastic in the waste. Cloth, 6%. Leather, 2%. Rubber, 0.5. The other materials, 3.5. Other materials, 3.5. So this gives you a brief description of what is present in a municipality. Maybe these numbers will be little plus or minus in several other municipalities in India. But if you go to a different country, these ratios might change, right? Now, then, okay, now you have done your physical composition. That means you have separated materials. You have found out their density. You have found out their moisture content, all that. But now the next aspect is chemical composition. What chemically is this material? So for chemical composition, what are the properties that you try to study? First one is called as proximate analysis. Proximate analysis, where you try to find out what is the moisture that is lost at 105 degrees centigrade for 1 hour. That means when you heat the solid waste, how much moisture will be lost? When you heat the moisture at 105 degrees. Why 105 degrees? Water will go into vapor state. Then volatile matter, which directly go to ashes, ash residue after combustion. So what I mean by ash residue is, if I burn 1 kg of waste, how much ash I will get? Say if it is paper, I get less ash. If it is wood, I get more ash. So that is the reason why we try to find out what is the ash residue after combustion. Then finally, fixed carbon remainder remaining in the, what is the carbon that is remaining in the waste? Fixed carbon. Even that is important. Then, okay, when you burn, you will get ash, but this ash will be in the dust form. But I don't want ash in the dust form. I want to convert it into a solid form, a brick or a pallet or whatever. That is what is called as fusing point of ash. At what temperature the ash becomes a single unit, a single solid unit. Then the next analysis that you take is ultimate analysis. So in ultimate analysis, you go for elemental composition of the solid waste. What is elemental composition that you try to analyze? Carbon. What is the percentage of carbon? Hydrogen, oxygen, nitrogen, sulfur, and what is ash after burning. Okay, next thing that is very, very important is your heating value. So many times you say energy from waste. What do you mean by energy from waste? You try to derive energy from burning waste. Now, if you want to find out how economically is this practice, then you have to find out, if I burn 1 gram, how many calories or joules of heat I am going to generate. If I burn 1 kg of waste, how many calories of energy I generate, heating value. How much heat I be generated by burning a unit quantity of waste. That is what is heating value. Okay. Now coming to solid waste management, what are the objectives? So what do you want to do with solid waste? What do you mean by solid waste management? First thing is to identify types of solid waste and their source. So what are different things present in solid waste, from where they are coming? Next one, to examine the physical and chemical composition. To examine the physical and chemical composition, just like I told you, the properties that I told you to analyze. So when you find out their physical and chemical properties, then you can decide where they should go, how they should go. Then the last one, to consider the elements involved in management. I will tell you what are the elements involved in solid waste management. But right now, the third aspect of solid waste management is to consider the elements are involved in solid waste management. Now then, what are the benefits of solid waste? Many times, if you don't know the benefit, you will always have a doubt. Why should I do it? Why should I do it? So that is where you try to come across this, what you call benefits of solid waste management. Benefits of solid waste management. What are the benefits? First one, sustainable development. So this is the larger picture. If you manage solid waste management, it is one of the goals of some sustainable development. So I don't know how many of you have heard. There are sustainable development goals. Those are called as MDGs. Okay, one of these goals is sustainable development. One of the goals of sustainable development is how effectively you are managing solid waste. Right? Then improved health and hygiene. How health and hygiene are improved if you manage solid waste? Many times when you find solid waste on the road, what happens is you find these waste giving bad odor. There will be a lot of decomposition taking place. There will be a lot of flies. There will be rodents. There will be mosquitoes. There will be flies. So many things. So all these are responsible for disease. If you remember rats flourish in solid waste management. Wherever wastes are there, rats flourish. What do you mean by flourish? They multiply in numbers. And all of you, I don't know how many of you know it, rats are responsible for a particular disease called as plague. Similar, and plague is very dangerous one, which we used to have several years back, several decades back. But these days, fortunately, because we are practicing better solid waste management, we are not encountering plague. But people suspect, I don't know, again, how many of you read newspapers. About few years back, maybe 7, 8 years back or more than that, in Surat, Gujarat, people suspected plague. But it was not disclosed. But it was so pathetic that Surat was struggling to survive during that time. All industry was closed. Everything happened. So that is what is improved health and hygiene. So control of water pollution. So generally what happens is, if you have solid waste, when it rains, the water that from the solid waste dump or solid waste will pollute water, surface water, groundwater. Any water that is flowing through the solid waste is polluted, which can pollute fresh water. Enhanced commercial values. Always you can find, I don't, again, this is, if the square yard of area, generally in municipalities and cities, it ranges from 20,000 to 50,000 rupees today. But if you have a solid waste dump next to your site, the value will be half of it. The value will be half of it. People don't prefer to buy it. So that is why, if your solid waste management is very good in your city, then your values are much higher. Enhance the aesthetics. So if you find litter all on the road, litter everywhere and anywhere, it is not a pleasant sight to look at. So that is the reason why you find what you call enhanced aesthetics. Aesthetics means when you look at something, it should look decent, it should look elegant. So that is what is enhanced aesthetics. Control of air pollution. As I told you earlier, when you are having solid waste, the solid waste starts decomposing, giving bad odor like ammonia, methane, H2S. All these are not very acceptable. They are foul odors. You try to reject these odors. Then the other thing is, like, many times people start burning this solid waste. Many times you find solid waste being dumped even in the dustbin. People put fire, knowingly or unknowingly. It is a very, very bad practice. Very, very bad practice. The reason being, when you burn solid waste, there will be a lot of smoke. That means a lot of carbon monoxide, hydrocarbons, all these. And in this solid waste, if there are plastic content, plastic components, then you get some compounds which are called as dioxins, which are cancer causing. So whenever you find smoke from dustbin, you try to prevent inhaling that. You put a kerchief or something to avoid that smoke, avoid inhaling that smoke. So solid waste causes air pollution. Enhancement of real estate values. That means if you have a very beautiful city where solid waste is managed well, then real estate values, just like I was telling you, 1 square yard is 20,000 to 50,000. If your area is very beautiful, well-maintained solid waste, then your cost of land will be 30,000 to 60,000 per yard. Better sanitation. So what do you mean by sanitation? Sanitation is keep up of the area. So if you have better solid waste management, it leads to better sanitation, better living, better conditions, better working conditions, right? Then one second. Okay. Okay, now what are important aspects of solid waste management? So what you do is, how are the materials flowing in the in the society? How do materials flow in the society? That means, where are these materials coming in? I have told you, you have plastics coming in, food coming in, vegetables coming in. How are these coming in? You also have to look at reduction in use of raw materials. That means, when you are using this, is there a possibility on reducing the raw materials? When you reduce using the raw materials, there will be reduction in generation of solid waste quantities. Then reuse of materials. Is it possible for you to reuse the material? Then the fifth aspect is materials recovery. So after reuse means in the present state, say suppose you have a bottle. After use, you can reuse the bottle. You can reuse the bottle couple of times. Then materials recovery. So reuse option is, not all materials have reuse option. Say plastic or paper. They cannot be reused forever. After reuse or sometimes without reuse, can there be some materials recovered from them? So that is what is materials recovery. Let's say food waste. It cannot be reused, but materials can be recovered from food waste. What material can be recovered? It can be converted to compost. Or methane gas can be recovered by decomposition. So some material can be recovered by adopting some practice. That is what is materials recovery. Then energy recovery. That means, say again paper. You send it for burning. You get some heat. Heat can be used to generate energy. So like that, what is energy recovery? Then day-to-day solid waste management. Because this 0.5 kgs that I was referring to you earlier is happening all over the day, every day, 365 days. No holiday, no Sunday, no Saturday. All 365 days, all through your life. All through your life, it will happen. So what happens is, day-to-day solid waste management. Say, suppose through some day-to-day solid waste management practice, if I am able to bring the 0.5 kgs to 0.45, then what are you doing? You are reducing the quantum of the problem by 5%. Or you don't practice day-to-day solid waste management principles, and this 0.5 becomes 0.6. What is that you are landing up to? You are landing up in a problem which is more severe by 10%. More severe by 10%. So that is what is the reason why you have to think about day-to-day management, right? So what is materials flow in the, how do you visualize this? So raw materials come into the society, they go to manufacturing sector, where, say again here, do we have solid waste management problem in forest? You don't have. Do you have solid waste management problem in village? Not much. You have solid waste management problem in a town? Yes, there is problem. Do you have solid waste management problem in a municipality? Yes, you have. Do you have solid waste management problem in a big city? Yes, it is big problem. So when you go from what you call smaller habitat to bigger habitations. The problem is becoming more and more. The reason being, human being especially, is not satisfied with what he has. He wants to always, what you call, improve the comfort of living, improve the standards of living. He wants to live more and more comfortable day by day. So that is the reason why you are generating more and more materials. Say, for that reason, lot of raw materials flow into the society. They go to manufacturing, primary manufacturing, secondary manufacturing, then they go to consumer, or then they go for, through manufacturing, you get some waste. That waste will go for disposal. After primary manufacturing, a product is coming to consumer directly. After use, that will go to disposal. Some materials which come to consumer, they are processed and recovered. They go back to manufacturing. Some materials that come to disposal, from the processing and recovery, they also come for final disposal. So you have all kinds of things. So wherever dotted lines are there, they are waste. So even when you do processing and recovery, not all waste can be recovered. Not all waste will go to the manufacturing. Not all waste will go to secondary manufacturing. Some waste will come to final disposal. So now, considering all this, suppose you reduce the raw material for a particular activity. Say, for example, the best example that is quoted is from last big cars. Again, it is an industrial example. So if you want to manufacture a big car, you require more material. If I manufacture a small car, that means all of you, instead of using big cars, you come to use of small cars. Then what happens? The amount of material required for manufacturing a car reduces, which means the amount of material that is to be mined. See, if you want to manufacture a car, you should get iron ore. Instead of getting iron ore 100 tons, if all of you convert into small cars, you may require 80 tons. I am only giving some numbers for you to understand. So if you require only 80 tons of material for manufacture of small cars and 20 tons of material is not mined. That means you don't mine 20 tons, which means you are reducing the waste that are coming from the mine. And more so, when you process 100 tons of ore, you generate some waste, say 10% waste. So what is this 10% waste? 10 tons of waste. But if you change from big cars to small cars, just now you told instead of 100 tons, 80 tons is sufficient. 10% of waste means 8 tons. So instead of producing 10 tons of waste during manufacturing, you are producing only 2 tons of waste. You are only producing 2 tons of waste, which means you have reduced your solid waste management problem by 2 tons. That means 20%. From 10 tons to 2 tons by 20%. But you are in a lavish society. You are one in the car, but you want to use a bigger car. Then what happens? Instead of 100 tons, you require more iron ore, that is 120 tons, which means you are creating more solid waste management problem. right? Any questions? I'm not sure. I want some responses from the participants. Am I too
Yes, sir.
fast? Am I too slow? Am I audible?
No, sir,
Are,
perfect.
are
Very
you
audible,
able to
sir.
It's
follow?
going
Very
fine.
Audible, sir, audible.
Audible, sir, audible.
Okay, excellent. Am I too fast?
No, sir, no.
No, sir.
No, sir.
No, sir. No, sir, it's okay.
You are able to follow my lecture?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
Okay, fine. Then I can
Yes, sir.
continue. See, the
Yes,
reason
sir.
is when I don't see you people, I don't know whether I'm able to reach you or I'm only talking against a computer which doesn't give me any response.
He hears you, sir.
Really, talking to a computer is talking to a wall like, no response. If you are in the class, I can see you, I can feel whether you are understanding or you are putting a blank face or you are appreciating my lecture or if I am boring also I can sense. But in this scenario, I cannot see anything. I'm only imagining that you are following and talking. So that's why I stopped here to ask you a question. Okay, fine.
Sir, we all believe in trust. Trust on some people. That's all.
No, that's fine. I'm not. That's why I told you initially. I believe that all of you are interested in this topic. That's why you registered. So I
Yes,
trust you
sir.
are
This is
listening.
pretty much informative.
Yeah, that's
This
what.
is very much informative, which is why I'm noting down all of the things. It's really insightful.
We'll share the presentation, but if you are noting down, you are welcome. We will put the
Thank you so
presentations
much.
on the classroom link where you can take it, or we can mail it also. No problem.
Yes, sir. Yes, sir.
Okay, sir.
This is also
Yeah.
this is also required,
Thank
sir.
you. Thank you so much, sir.
Yeah, we'll give it to you. No problem.
It will help a lot,
Okay.
sir.
Okay, great. Okay, this was the example that I quoted. Reduction in use of raw materials when you buy small cars. And this was a example that I am quoting. From 1950 to 1984, there was a reduction in size of cars by 20%. That is the same example I quoted in terms of numbers. So when you reduce the size of car, it reduces steel demand by 20%. It leads to less mining ore, less waste. Reduction in raw materials leads to reduction in jobs. Now again, this is a conflict, economical conflict. So there I am saying I am reducing solid waste problem. But unfortunately what happens is, when I want to make a big car, say I require 10 people. 10 people are to be employed. But when I want to make a small car, I require only 9 people. That means one person is losing a job. So now you have to make a choice between, should I create employment or should I reduce solid waste or should I reduce the cost of the car? So again, there is no answer for this. If you go and ask somebody, he will say, oh, if you reduce size of cars, people will be unemployed. Less jobs. But at the same time, what happens is, when you reduce the size of the car, the cost of the car will reduce, more cars will be required, more cars means more jobs again. So there is no one kind of iteration. There can be several kinds of iterations. However, the policy depends on the country, national policy. What does the country want? Is the country looking for more employment? Or is the country more aware or more conscious about solid waste, reducing solid waste problem? So if you want to reduce solid waste management, what may come? He will say, no, all small cars only. We will not give permission for big cars. Or there are several countries which say the proportion of they fix proportion of small cars and big cars. If 80% are small cars, 20% are big cars. So they don't say all small cars, but they only give. And I was reading somewhere, some countries, they insist the number of cars to be sold in a year, not more. And one example that I have read is in Singapore, every year they decide how many number of cars that can be sold next year. If that number is over, however influential you are, how much money you have, you will not get a car. That means they are trying to fix the number of cars that are there in the country. There are several reasons why they fix that. That's why I told the policy depends on the country, not on the things. Increase in oil prices leads to reduction in the use of oil, but stress on alternative energy. Again, so when you want to control consumption and reduce waste, there are different kinds of practices that you can adopt. Okay, so that's what I wanted to highlight. Then, one more example that we can quote for reduction of solid waste quantities is amount of materials used in the manufacturing. How do you reduce? Simply that. Increase the useful life of the product. Increase the useful life of the product. Amount of packaging. Kamlesh. Kamlesh, good morning. Okay, I will join in 10-15 minutes. Okay. Okay, fine. Okay. So another thing that comes into picture is increase the useful life of the product. Increase the useful life of the product. Again, I will quote an example here. Many of you must be using cars. In cars or motorcycles or any other vehicle, you have a tire. You have a tire, right? Rubber tire or whatever, synthetic tire. The life of the tire, when you compare 20 years back and today, we have come a long way. We have come a long way. That means earlier, the tires used to last for 20,000 kilometers on road. Today, the quality and the material that you are using for a tire will withstand 40,000 to 50,000 kilometers, which means in a particular period of time, earlier, say 50 years, you were supposed to use 2 sets of tires. Now you are using 1 set of tires. What does it mean? Less production of tire. And when you, after use, what will happen to the tire? What will happen to the tire? Tire is waste. It goes to dump. So you are reducing the waste. You are using less quantities of material. Instead of 2 tires, you are using only 1 tire, which means you are reducing the quantity of tire production. At the same time, you are reducing the waste that is going to the thing. Then amount of packaging. Again, for this, I should quote one example. You buy a mobile. When you buy a mobile, what is the size of the mobile and what is the size of the pack that you get? The size of the packing that you get is at least 5 to 10 times more than the size of the mobile. Am I right? So when you buy a mobile,
Exactly.
yes. So where is this packing going out? This packing is thrown into the dustbin. If not that day, maybe a month later, or sometimes if you forget, a year later, it goes to the dustbin. So your functional part, just like I told you the pen and refill example, Your functional part is only, you see, you want a mobile as thin as possible, as light as possible. But your packing is very bulky. The packing is going to solid waste and contributing to problem. So amount of packaging is also a very, very important example that we should take. That's why several times you have to return the packing to the manufacturer itself. Why do you carry it home? You should leave it in the shop. You should carry only a mobile. Why you want to carry? This practice, see, that's why we always tell, we are not very conscious about environment, conscious about pollution, conscious about problems. This practice of returning the package existed in Germany in 1996. In 96, I went to Germany for the first time. So when you go out abroad, generally you go for shopping. So as usual, I also went for shopping to buy a few things. Then when I was checking out, that means making the bill. After the billing, I find all Germans removing all the package, wrappers and everything and leaving in the shop and carrying only the item. I only had a doubt. I asked the professor who was with me, why are they doing it? To reduce the solid waste heat. If it is with the shop fellow, he will send that packing to again to the shop, manufacturer, so it can be reused. If you carry it home, it becomes a burden to the municipality. So that was the awareness that people had. But today, I don't think we have that awareness. You go to a shop, he gives you in a plastic cover, you take it and you ask, okay, please give me another cover. Which means you are multiplying the problem. So this is about the packaging aspect that you have to think about. So increase in the useful life of tires by 50% or mileage leads to reduced quantity of tires and wastage. So this is the example that I quoted. Okay. Reuse of solid waste materials. Again, this is another thing. Of course, in this aspect, we are doing very good. We always try to reuse plastic bags, bottles, cans, tins to the extent possible. Then only we throw them. So reuse of plastic bags and other purposes, reuse of plastic cans to store vegetables, reuse of bottles. So these are the important things that you can reuse, hence reduce the waste that is going to dustbin. Recycling and reuse. Again here, as I told you earlier, even this aspect, we are little, conscious in the sense you try to sell your newspaper, which goes for recycling and reuse. Newspaper generally goes to cardboard manufacturing or whatever. You try to sell metal. You try to sell glass, which also goes for recycling. So which means it reduces the burden on the municipality in handling solid waste, right? So what are the materials that can be recovered? Metals can be recovered, plastics, paper, glass, rubber, food waste. So this is the aspect that we will be talking about for the next 5 days. What are the materials that can be recovered from food waste from this aspect? So what we see. So what are different items in paper? Old copies, old books, paper bags, newspaper, greeting cards, cardboard box, plastic, containers, bottles, bags, sheets, glass. Bottles, plates, cups, bowls, miscellaneous, old cans, utensils, aluminium, even your iron utensils, all that. Furniture, that means like chairs, plastic chairs, your coolers, all these are sold generally. Okay, just look at this particular aspect. You look at Germany, you look at Japan. Japan is one country which sets an example. You look at Japan, the amount of recyclables, 50%. They are so conscious that the materials that are recycled, they will go for recycling. They will never go for landfill, they will never go for incineration, which is a polluting activity. Then incineration, again you see Germany 30%. That means they waste to energy. Waste to energy is the best. Then landfills, very small percent, about 15 to 17%. Not landfills is more, 55. Only in Japan, because they don't have enough land. They are very conscious about landfills, about 28%. Then come to USA. Again, USA, they don't have, they are very lavish. Their waste production is very high. They don't think about recycling. They don't think about incineration. They practice more landfills because the available land is unlimited in USA. So that's why I told you, whatever policy you have depends on what is the priority of your nation. What is the priority of your nation, right? Steps involved in recycling. So when you want to recycle, what do you do? So the waste should be collected from doorsteps and commercial places. That's what this example that I quoted. In Germany, from commercial place itself, from the shop itself, waste is collected rather than from shop, it goes to doorsteps and comes back. So when it goes to doorsteps and comes back, then there may be some mixing also. Here from the commercial place means it is segregated, 100% segregated. Segregated means only specific item. There is nothing mixed to that. Collection of waste from community dumps. This is very, very difficult. That means in the dump, say for example, I quote again example of Warangal. Warangal population is 10 lakhs. Say we are producing 0.5 kgs per capita per day. 10 lakhs into 0.5 kgs. How much?
5 lakhs.
Huh? 5 lakhs.
5
5 lakhs
lakhs.
is how many tons? Divided by 1000. Right? 500 tons. Is it possible for me to pick up material from 500 tons every day? It is impossible. How many people I have to employ to pick up that material which can be recycled from 500 tons of waste? That is the reason why today in many municipalities, all of you must have observed, the wastes are to be segregated in 2 dustbins. Am I right?
Yes, sir.
In municipalities, Government of India has given 2 dustbins to each house. 1 dustbin for food waste and
Blue
organic
and
waste.
green. Dry, yes, dry and wet.
Yes,
Waste.
dry and wet. The other waste is for paper, plastic, cans, glass, all that. And I am not sure how many of you are doing or how many of you have seen the segregation taking place. As I told you with a simple example of Warangal, 500 tons of waste to be segregated, how many people I require, how much labor I have to employ. And no labor is prepared to do this because it is a dirty job. So if you are able to segregate in your house itself, it is the easiest job. If you do it, recycling becomes much more easy and you are helping the municipality. You are helping the environment. You are helping this society. Okay. Then collection and pickup of waste from final disposal site, even these two, last two are, I mean, they are on paper possible, in practice not possible, right? So advantages of recycling, why we have to recycle, leads to utilization of raw material. That means, so when you are making paper, 20% recycled paper can go in. So which means you are reducing raw material usage. Reduces environmental impacts arising from waste treatment and disposal. So you are reducing the waste. See, instead of 0.5 kgs of waste going to the disposal site, if I segregate only 0.25 kgs. Again, if I take example, instead of 500 tons going to disposal site, only 250 tons will be going. And this 250 tons which it goes to recycling will give you some regeneration, will give you some material, will give you some value, right? So that is what it is to be done. It saves money. You are getting some amount of money. It reduces the amount of energy required to manufacture new products. I told you, 20% of paper or 20% of plastic or 20% of ton metal goes for manufacturing. Then it saves you money. It saves you money, right? So energy recovery is possible. 50 to 70% of materials are organic. I told you. Even from the kitchen waste, energy can be recovered. Even from paper, energy can be recovered. Even from plastic, energy can be recovered. So that is why you have to look at potential for energy recovery is very high. But what we are doing is we are not practicing it completely. Generation of heat by burning organic material is a popular option. One example again I will quote, that is historical example. The cow dung in villages made into cow dung cakes. Am I right? Cow dung is made into
Right.
cow dung
And we
cakes.
can use it for
Yes,
energy
sir.
recovery.
Yes.
Yes,
You
sir.
can use it as a fuel for burning. The same thing, if you can segregate all the food waste, which I was referring to, 50%, and if you process it and make it as cake, dry it and make it as a cake, use some binder, and today you can create pallets, fuel pallets from this organic waste using some binder material. Then that will be used for burning to generate energy. Or if you separate the organic component, it can go for anaerobic decomposition like your gobar gas plant, and you can generate methane which can burn again. Just like somebody is telling, RDF, refuse derived fuel, is the order of the day, where you use new technologies like gasification and pyrolysis.
We can also use the biomasses and agriculture waste for biofuels like
Yes,
bioethanol, biodiesel.
yes. Please, yeah, these are all the options that are available when you are only able to segregate. When you mix everything like mixture, it is not possible to do these practices. It is not possible to do these practices. So what do you mean by day-to-day solid waste management? As I told you, problem is complex. Magnitude of the problem is very big, and it is a very costly undertaking. I tell you today, you go and talk to any municipal engineer, municipal commissioner, or municipal mayor. You go and ask him, Sir, what do you think is biggest challenge that you are facing in your job? He will neither say water supply, because he is also responsible for supplying water to the community. He will never say wastewater treatment, because he is responsible for treating wastewater and disposing, collecting wastewater. He will definitely say solid waste management is the biggest problem that I am facing. You go and ask any municipality employee, field people. So elements of solid waste management need a consideration to solve this problem. You require a consideration to solve this problem. And most of these solutions that you find in solid waste management are mostly management solutions rather than engineering solutions. Better management. You should be a good manager rather than an engineer to handle solid waste management. Right? So this is the other thing. Okay, these are the elements of solid waste management. So I think I'm going to stop here because I will take some questions. I will continue with this lecture tomorrow. Any questions? So we'll spend 5 minutes for questions. Then I will give you a break for 10 minutes. Then we will have the next session by Dr. P.V. Rao. Because there is a slight change. The types of composting and all that will be covered later, because I told you my colleague is traveling. So we will reschedule it some other day. Okay. Any questions? Some questions? So as of now, we have 101 participants. Yeah.
Very good morning, sir. I am Dr. Nanamurthy, and I am Mr. Viluppuram
Okay.
Chambers. If you go for the solid waste management, as far as our India is more and more, and we are dumping the earth, dumping the waste. How they will recover? For example, when I went to the Delhi, they will using the solid waste management. After that, they will tree plantation like that. They are going. Any other our state will do like that?
So strictly speaking, whether in Delhi or whatever, we are not, as of now, using best practices. Now we are slowly changing to adopt best practices. If there are best practices, they are here and there, which are happening. The best practice that we are trying to attempt, the biggest problem in the solid waste management is segregation. That is the reason why today Government of India has spent a lot of money, started creating a lot of awareness among people to see that wastes are segregated so that they can be handled better. If wastes are segregated, recovery becomes easy. The organic component will go for either composting or energy recovery or whatever. So unless this happens perfectly, the other part doesn't happen. Okay, that is first thing. The second thing, you were referring to Delhi. In Delhi, people say they collect waste, they will throw it on the outskirts. Maybe I don't know how many of people have traveled to Delhi or nearby Delhi or Delhi. If you see the outer ring road on Delhi, you will find mountains of solid waste.
Yes, yes.
You will find mountains. And you know, a few years back, from this mountain, like landslide, the solid waste slipped onto the highway and there were accidents. There were some casualties. So what is being done today is not a correct practice. Even the landfill, they call them landfill. Those are not landfills. These are only open dumps. I will come to open dumps in my next lecture. Okay.
Thank you, sir. Thank you.
Any other question?
Good morning, sir. I am Mahendra from JNTU, Hyderabad.
Okay.
Sir, is there any possibility of waste to energy will be successful in India, or any as segregation is a big problem? And is there any other country which is successful in the same?
Okay. I tell you, because you told Hyderabad, I tell you one waste to energy plant which was working in Vijayawada, very close by, about 200 kilometers from Vijayawada. It worked
Yes,
for
sir.
a while, but later it became defunct. The challenges in waste to energy is, again, first challenge is, are you getting homogeneous material which can burn? First thing. The second thing is, if I design a waste to energy plant for 1 ton of waste, every day I should feed 1 ton of waste to the plant. If I am feeding 0.5, tomorrow 1.5, the plant will not work properly. So I should ensure when I am designing that this plant is designed for 1 ton and I should get 1 ton every day. Unfortunately, what happens is in India, or in, I think that is a challenge in other countries too. When you have a wet season, what do you mean by wet season? Rainy season.
Rainy season.
In rainy season, what happens is during collection, during transportation, this material becomes wet. And this material, when it is wet, it doesn't give enough energy when it is burnt. So if you want to make this practice successful, your municipal energy plants, municipal waste energy plant should be designed for co-firing. What I mean by co-firing is, some amount is municipal solid waste, some amount is either coal or something else, so that your plant is running continuously without any break. But people have not designed them for co-firing. That's why the experiment was not very successful. That is the reason why today there is a lot of research underway where people are converting solid waste to pellets. Then these pellets can be used in incineration. These pellets can be used in incineration. 1 second. No? You please call my research scholar. I have shared you on his number, right? I'm in this session. You please call my research scholar, or I will take your call 10 minutes later. Okay. Hello? Yeah. Any other questions?
Sir, recently there is a plant started in Hyderabad in Jawahar Nagar, which is outskirts of Hyderabad. The situation of the plant will be the same like in Vijayawada, but it is successful in Sweden, no, sir.
Okay. I see, most of the time what happens to our people is something worked in Sweden, they think it will work here, and with a lot of what you call aspirations, they employ it. They don't study what are the practical difficulties that we face. And to be very honest, I only have seen what is that incineration plant was installed in Jawahar Nagar, but I have not seen it yet. I am not aware of what technology it is using, whether it is co-firing or single firing, how they are managing the what you call feed to that. Only if I study that, I can comment on that. I also have seen only in newspaper. Okay.
Yes, sir. Thank you, sir.
Any other questions?
Good morning, sir.
Yeah.
Sir, myself Rakesh, MTech second year at Nati Warangal. Sir, my question is, as one of the problem in managing the solid waste is lack of collective efforts. So, sir, how to deal with this problem so that to make people awareness to put their collective efforts to manage the waste properly? Thank you, sir.
Again, here, there is no single solution to that. Say, nobody has a magic stick to say from tomorrow everybody will segregate, everybody will work in this aspect. Slowly things are happening, and I think when you compare 10 years or 20 years back, we are much better off today. I think maybe in due course of time, we will also have a better solid waste management practices that people are using. Okay.
Sir, I hope there is some policies, some model like public and private partnership that can be more effective than
Yeah,
some.
even private partnership is used. Even in Calcutta, I think they are employing NGOs. All practices are being used. See, the problem is at the source, what is happening? At the source, it is not happening properly. People are not bothered. Say, for example, in Warangal, they have removed dustbins. They told all waste is collected by people. You have to give it to them. And if you litter or if you throw waste on the road, you will be fined 500 rupees. And municipality is taking care of this, but still I find people throwing it on the roads. And the municipality will put a, put a banner there saying that if you throw waste here, 500 rupees fine. Then they will change the spot by 100 meters. They are throwing there. See, people also should be disciplined, environmental conscious. Then only this will work. Slowly it is working. I think I assume at least 80% are conscious today. Only this 20% also will come in line.
Thank you, sir. Thank you very much.
Good morning, sir.
Yeah.
Sir, in foreign countries, we know that the municipal solid waste is a revenue generating business nowadays.
Yes.
As like foreign countries, for the garbages, they are giving the revenues to the generators, that is the public. As like, why can't we implement those things in our country?
No, it is all like, see, if it becomes successful, it is revenue generation. Now, you have to make it successful before you try to ask for revenue. See, if you give a private party today for him to operate and all that, if he is successful, then he can transfer revenue to the public. But as of now, he is not able to do it. That is the problem.
Oh, okay.
Okay. I have another session tomorrow and later today. I will continue with the discussion. You take 10 minutes break. It is 10:25 now. 10:35, we'll ask Dr. P.V. Rao to log in for the meeting. Right? Okay.
Yes, sir. We'll start.
Okay,
We'll start
sir.
it. Thank you.
You will start
Okay,
it right away?
Yeah, I will start at 10:35, sir. As you told.
Okay.
We
Because
give 10
take a
minutes
break,
break. After that,
because
I'll join.
in the virtual session, if you don't take a break, then after some time your mind is blocked. It goes,
Yeah,
I
yes,
mean,
sir.
it is saturated. It doesn't take anything in. Okay. Thank you. Thank you. And most of you are disciplined. I am very happy with that. No disturbance. And I hope you will continue with this same kind of discipline till Friday. Good luck.
Thank you, sir.
Thank you. Bye bye.
Thank you, sir.
Thanks a lot, sir.
Thank you.
Sir, can we get presentation PPT?
Yes, you will get all the PPTs of this program towards the end of the FDP.
Okay, sir. Thank you, sir.
Good morning to all of you.
Good morning, sir.
Very good morning,
Yeah,
sir.
shall we start?
Yes, sir.
Yes, sir, sure.
Good. Are you able to see my screen?
Yes, sir. Perfect.
Yes, sir.
Okay. Welcome back to the session. Today I'll be talking about decentralized and centralized composting, and I will be talking about what is composting process, how do we plan strategies for setting up centralized composting or decentralized composting, like which is good. Shall we go for centralized or shall we go for decentralized? What are the different factors which influences for planning this type of process? What type of data we need to have in our hand before planning such a system? Nevertheless, when you select any type of composting process, let it be centralized or decentralized, then what are the various influencing factors for this effective implementation of this composting process? What are the various process parameters which influences the efficiency of this process? And of course, very little information about compost quality standards. And finally, I'll be giving my concluding remarks. Now, before going even introduction, I just would like to recall some of the issues which were raised by Professor Chandrasekhar in his earlier talk about composition of municipal solid waste, how it look like, what are the different fractions of this waste, and various problems of this waste, and as well how do we have the strategies for managing the waste rather than engineering solution. Sir told that it is more with management rather than engineering. Of course, engineering is there, but more than engineering, we need to have management aspects as well. Something like reducing, reusing, recycling, and so on. So, having understood those things, let us move forward to understand my lecture. Initial 10 to 15 minutes, I'll be talking about generic composting process. What exactly is a composting process? How do we deal with? What type of, as we understood already, the typical composition of municipal solid waste, which components of this municipal solid waste can be taken for composting, and how do we handle them? That is aspect I'm going to discuss in the next few minutes. So if you look at it, the urban bodies, if you look at rural India and urban India, the big difference is rural India, the lifestyle is designed, or the people lives in much coherence with the environment. The amount of waste generated will be much more less, and people are not living in a concentrated manner. Like, I mean, less number of people are living in a significantly large area when compared to urban environment, and waste management may not be a big problem in rural areas. So mostly my emphasis, what I am going to talk in this particular lecture, will throw light on medium to large scale towns, cities. So if you look at it, our country, which is also stated to be a developing country, we have a most alarming problem. As Professor Chandrasekhar mentioned few minutes back, if you ask a municipal engineer what are his problem, he would state that solid waste management is a problem, even though he is responsible for water supply, he is responsible for wastewater treatment, he is responsible for solid waste management. Out of the core civilian supplies, his biggest problem is solid waste management. And today, the one more level or one more degree of the problem is the waste mostly being collected by the municipalities with a lot of advertising. Last few years, we have seen that big change, quantum change in the attitude of government also, requesting the people to generate the whatever waste they are generating, to segregate and hand over to the waste handling person. In spite of several requests and awareness programs, still people are not able to segregate properly, leading to composite waste, heterogeneous waste collection, and finally the entire waste that is going to landfill sites rather than going to waste handling facilities. This is causing, and a simple calculation told by professor, particularly if I take the case of Warangal, which is generating around 500 tons of waste per day, managing that 500 tons collection, transportation, managing these 500 tons becomes a gigantic problem. Rather, if it is properly segregated, the decomposable matter happens to be around 40 to 50%, leaving only 250 tons per day to be handled. The remaining 250 tons can be easily recycled and reused. Whereas the waste that is to be managed becomes only 250 tons, maybe half of the problem is solved. So instead of solving the problem, we are magnifying the
Sorry
problem.
for interruption.
Please.
Excuse me, sir. Sorry for interruption.
Sir, please.
Sir, we
Please,
are seeing
please,
only
please.
the first slide. We are seeing only the first slide.
Oh. Is it changing now?
No, sir. Not
No,
changing.
it's not yet, sir.
Even now?
Can you please close the PPT and can you open again,
No,
sir?
sir.
With more.
Okay.
It is changing now, sir.
Yeah,
Yes,
it's
sir. Now it's
changing.
It
changing.
is okay.
One
The
second.
introduction.
Now
But
okay.
you can keep in presentation mode, sir.
Are you able to see now?
Yes, sir.
We
Yes,
are
sir.
seeing
Visible.
introduction page.
Yes, sir, it's visible, but it's not in presentation mode.
It is in presentation mode right now? Is it in presentation mode right now?
No, sir.
So how it is looking like now? One second. I will disconnect and reconnect.
Okay, sir.
Okay, sir.
Okay, fine.
Check this. The
Perfect. Yes, sir.
Okay, okay.
Yes,
Good.
yes, sir. It's visible and it's in presentation mode now, sir.
Sir, now your voice is not audible. I can't hear you.
Yeah, you were able to hear my voice now?
Yes, sir. Now it's
Yes, sir. Now
Yes,
it's
sir.
audible.
If you look at it, your typical in urban. how it
Yes,
looks
this
like.
is visible now.
Yeah, you can see that street, how people
Yeah.
are dumping
Yes,
the
sir.
waste.
Everything is
yes, sir.
perfect.
Yes, sir. Yes, sir. We
Okay.
can see that.
Yeah, fine. You can see
Yes, sir.
that
Good to go.
screen here. This particular screen shows you how we are littering on the streets, how solid waste is being dumped. So one figure, the left-hand side figure shows you in urban street how it is flooded. The right-hand side figure shows you the entrance of a village, how it look like. Even rural areas, how they are getting polluted, it is being shown. This is the state of FI today. Now, if you come to, for example, urban areas, say, take the typical case of Warangal. Warangal, when you are entering Warangal from Hyderabad, at the entrance you have something called Rampur. So there it is the official landfill site for the government. So what is happening is the citizens of Warangal, at least I would say not entire all the citizens, a major fraction of citizens still they are not segregating the waste in spite of several awareness programs being organized by the government. As a result, they are giving unsegregated waste to the waste handlers who are collecting, we are going to the door-to-door collection. Certain cases, I myself seen people to be handing over the segregated waste to the waste handler, but lack of maturity by this waste management handler, the person who is collecting, he is mixing the waste. So there are problems from both the side, from execution point of view and from generation point of view. As a result, they are getting the mixed waste and they are taking this particular waste altogether to the landfill site. Because as it is a mixed waste, no single technology is available to handle the mixed waste in the entire world. Every technology has its own limitations, has its own specifications about what type of waste suitable for what type of method. So if you are taking a heterogeneous waste containing different materials in a different composition, it becomes almost a challenging task for a single technology to handle. So ultimately the entire waste is going to landfilling, causing to water pollution, several diseases that are arising because of the splurging of mosquitoes, and sometimes this waste, if it is catching fire, unlimited smoke is emanating from these landfill sites, and if the dump, whatever they are putting onto the landfills, having even putrescible matter leading to degradation, and as it is unengineered, or I would say rather not engineered, some anaerobic conditions leading to be developing, leading to generation of greenhouse gases like carbon dioxide, methane. Also, sometimes this anaerobic digestion also leaves other odorous gases, mercaptans, hydrogen sulfide, and finally, for a city like Warangal, 10 lakhs population, 500 tons per day, we keep on dumping, the landfill site gets filled, and it necessitates once again formation of another landfill site. So that is the degree of problem. So that is the present situation. Now, what exactly we wanted from present situation? We want transformation. What type of transformation we wanted? If I want transformation, then obviously my next question is, why should I change? Or what are the driving forces? Why I need to have a composting system? Because see, my lecture, even though we have lots of problems with the solid waste, and there are n number of technologies available for managing the municipal solid waste, my primary emphasis will be on only composting. And particularly, whether I need to go for centralized composting or decentralized composting, which technology I should choose for. So that will be my objective. And for that, what are my driving forces? Why should I go for this such a technology? Because having such a technology will bless me with a good environment where I can live happily. Not only that thing, if any of this, if you don't manage the waste properly, it may cause disease that may reflect on the person's health, that may loses the person's working days. Like if you are sick, you cannot go to work. So you may not do, if you don't go for work, you may not earn that day's bread. Not only that thing, if you are sick, you may have to spend your hard earnings. So leading to poverty. So a clean environment or safe environment also gives you poverty alleviation for these people. And as some of my friends were mentioning, this is successfully being implemented in some countries. Of course, we can also join the group by thinking, by implementing the technology properly. That gives us a good business opportunity, and we can also generate income out of which, and we will have a reduced environmental pollution. And as we are using lot of material for reusing and recycling, we have a resource protection. We need not mine the resources for want of fresh material, because as some of our needs are met from recycling and reusing. And ultimately, if you are using composting, you are having, at the end of the process, you are converting the material, that is the waste material, into stabilized end product, which can be reused back to produce harvest. So our farmers can use that as a manure, which will improve the soil conditions and will be substitute as a nutrients when compared to synthetic chemical fertilizers. So these many driving forces are existing for setting up a new composting system. So having these driving forces in our mind, keeping the present situation, this particular figure shows us the road ahead. Why we shall go for a composting plant? Particularly here I written decentralized. The reason why, and one more point what we need to understand is decentralized to centralized. The exact decentralization to centralizations, the differentiation, if you want to understand, it is very thin line between that. Decentralized can be as small as at very house level, a group houses, a small community. After that, if that goes beyond certain capacity, we call them to be centralized composting plants. So I am having a clear demarcation also, what exactly meant by centralized, decentralized. I will show with the help of figures. So nevertheless, whatever type of system you are following, what we need to do is, we need to have a proper house-to-house collection system that will house-to-house collection with a segregated waste. And particularly the commercial establishments are very, very important points. You should not ignore those components which are also generating significant quantity of waste, particularly vegetable markets, even supermarkets. They are also having a lot of packing material. If you don't properly collect and utilize them, and that will be a problem. So after collecting these materials, then we have to identify which materials have to go to waste processing facilities, which fraction has to be taken to transfer stations, and finally, after taking the all materials which are to be taken for everything, and finally something left out, approximately only 7 to 10% finally will go to landfill site. For example, this case, if I am taking today in Warangal, we are getting around 500 tons of waste. Approximately 10 to 15% only is going to now recycling and reuse facilities. Approximately 90% it is going to landfill site today, but by following this particular flow chart, it will just do the reverse. Around 10% only will go to landfill site, thereby enhancing the opportunities. Like all threats, whatever we had problems, now all the problems are converted into opportunities. Now, before going to decentralized and centralized composting, I would like to show what is composting. Like you have different type of material. All these materials, all these waste which are produced in our day-to-day life, after its primary use, what are left outs, we collect them in a dustbins like this. And this material, this particular bin will convert this discarded material, particularly the putrescible material, into a compost. This compost can be used for farming purposes, agricultural purposes, which will give a good yield, thereby the entire process to be sustainable. So such a beautiful system. The only problem is, if I want to compost here, my biggest problem is the quality what I am collecting here. If my product whatever here available here, if that is not meeting the quality requirements of this particular bin, then I may not be able to use that particular thing. So that is the most important thing, that is the most challenging task. So we need to consider several points before making the compost. So what and all I am going to consider. So the first point is, where will you place your compost bins? That is for decentralized or household level composting. Second thing is compost pile. The compost pile refers to centralized composting. Like for a town together where I do it. And how large your compost heap will depend on many things. Something like how much space you have in your garden for composting. That's what we call it as decentralized composting. The kind of materials you'll be using to make the compost, and the compost once you are getting, how do you plan to use that? That is also an important thing. Who are the takers, and how much time and effort you can really put from your side for making and as well as spending the compost. How will you keep your compost pile spick and span? So these are the points you need to keep in your mind while planning your compost facility. Next thing is, when you start making your compost, we have to keep something like which microbes. These are not managerial aspects. These are technical aspects. As a civil engineer or as a waste processing engineer, you need to have information regarding which microbes are responsible for digesting and decomposing the compost. When this compost pile starts to heat up, what are the chain reactions which are happening? What is the fate of this organic material? How that is going to be decomposed? What are the end products? And how much temperature it can produce? And this plays a very, very important role. And this is something like a blessing feature of composting. Composting, the heap can go to 76 degrees Celsius. Then anybody can think of this composting is not a environmental, this composting is not an environmental problem. Hello? Any problem?
Classroom.
Somebody is talking. Any problem?
No, sir. No.
No, sir.
Okay, I request you to maintain silence. If you're, please mute yourself, and then, am I audible right now? Hello?
Yes, sir.
Yes, sir. It's going on good.
Yeah. So, in case of any difficulty, we'll have some time for discussion at the end. Okay, don't worry. So, the temperature, the increasing of temperature in composting is something like one important feature of this composting. As I told you, centralized composting, we take the material to open space and we make waste dumps, waste heaps, particularly with the putrescible matter. When we are making a heap, everybody gets a question: when I am storing material like that, will it not attract mosquitoes? Is it not going to cause nuisance? And the answer for that is this particular temperature. The heap will have, the inner core of a heap will have approximately 76 degrees Celsius, making the mosquito breeding, like if at all mosquitoes stands on that and breeds, and all the eggs will be getting deactivated. It will be killed. So that is the biggest advantage of this aerobic composting. And particularly this compost pile cools down, it may mean two things. One thing is, if it is not having temperature, that means the composting is complete. Or there is another alternative, that is what, because of lack of favorable conditions, the lack of proper conditions, endemic organisms, that is, some organisms which you are not expecting to take part, suddenly they start playing the role. In such a case, we will start smelling very bad from the composting, and temperature also suddenly drops. In such a case, we have to immediately start our remedial actions to regain or to re-provide the actual conditions which we are aiming for. And particularly if it is a successful process, after making the compost pile, the heating continues up to 2 days. And subsequently, we have to turn the pile for every 2 to 3 days in order to provide proper ventilation and to enhance the decomposition of this organic material. And this type of process we can follow in arid to semi-arid areas. If you want to take up such a composting process in areas which are susceptible for heavy precipitation or precipitation for most of the seasons in a year, then open composting is not possible. Then we may have to protect the compost heap from rain. Otherwise, the pile will receive excessive moisture, leading to water problems which are associated with the improper composting or illicit dumping. The same problems are going to be repeated even in case of engineered composting. So, based on the climatic conditions in an area, we have to plan, is a covered composting or uncovered composting. And from implementation point of view, it is always better to have a smaller compost heap because it is easy to manage, and as well as the air supply will be much easier, so that the decomposition also takes place quickly when compared to larger pile. But there is disadvantage as well with a very small compost heap. If the small compost heap is compost heap is very small, then you need to have more area. So we need to strike a balance based on the type of the waste and moisture, and based on the land drainage conditions, based on the temperature what we are having, ambient temperature conditions, we can plan what should be the normal height of the pile and what type of machinery we are using for turning. So then we can decide. So this is how, as a typical household level bin composter, how it looks like. Now, how do I make a bin? How do I fill the bin with the different waste materials? Shall I put it whatever I get it? So better we understand certain logic, certain fundamentals before myself to prepare a compost bin. There is a terminology called green and brown. In composting, we have something called green and brown. The green refers to young sappy material that degrades, mostly putrescible matter, and are high in nitrogen. Example like poultry manure, tea bags, cut flowers, young weeds, fish meals, coffee grounds, soya bean. Okay, these are some of the material which I call them to be which also to be green. And brown, I am having something called wood chips, sawdust, egg cartons, shredded newsprint office papers, shredded tree barks, paper bags, paper towels, which are usually dried, are rich in carbon. So what we do is we make use of both the greens and browns together and prepare the compost. And we have to be a little bit careful what not to put. So even if we don't put the proper combination of greens and browns, like how much green I have to put to how much brown, of course there are good combinations which I will be telling in my lecture. Rather, there are certain material which doesn't fall into green and brown, and if you put them into composting bins, particularly a decentralized composting, and that leads to a community problem also sometimes. For example, if I am doing composting at my household level and if I am not doing it properly, that bin not only smells me, and the smell emanated from the bin also become a problem to my neighborhood. So certain materials are not suitable to make the compost. Those are nothing but, why? Because they do not decompose, something like plastic, styrene, glass, metal. This anyhow, we will not do it. Sometimes we may overlook some material, and we try to put, if you try to put that material into the composting bins, particularly animal bones, fats, meats, fish scraps, greasy items, and other dairy products, and they becomes problem because some of the rodents, they can enter into your composting bins and start creating all problems. And another problem is this material also causes for the emanating objectionable odors. So we shall restrain from putting this material into composting bins while performing the decentralized composting. And how do I know? When I know that the composting process is complete. For example, I am taking a bin and I know I am taking certain proportion of green, certain proportion of brown, and I'm adding them, putting in layers, waiting for certain time. My bin is filled. Now, how do I know that how many days I have to wait? And how do I know that the material within the bin is composted? So there are certain benchmarks. One benchmark is whatever you are putting in, that turns into a dark soil. And when you are actually filling the bin, you know it's their identity. You know it is a green material, you know it is a brown material, you know everything. But end of the day, you will not be able to recognize what you really put into that. That indicates the composting process is complete. And once the composting process is complete, then that particular material can be used as a fertility improvisation for the soil. And how much compost you have to put in the soil, that depends on the use of your field. What is the real use of this particular soil? What type of crop you are growing? What are the crop requirements? Accordingly, you use the compost. And the well matured compost will look like this way: completely non-sticky, non-smelling, like a powder form. It will not stick. It will be in dark brown color. Now, there are basically two metabological pathways, particularly for composting. We call it as aerobic composting, that is mostly practiced everywhere. This aerobic composting involves conversion of different waste materials produced in our domestic life using a particular reactor, which we call them to be a composting vessel or composting bin. This bin will protect the material being exposed to outside environment, and the bin will also facilitate the optimum conditions to develop for this material for its proper conversion into end products. And sometimes, to accelerate the process, we may need to add oxygen. Sometimes we allow the oxygen to supply to the bin naturally. If we want to have still more faster rates, then we may also use artificial systems of supplying oxygen to the bin to accelerate the process further. Finally, converting all the raw materials into finished compost, which will have rich nutrients and healthy microorganisms, which will add number in the root zone for its growth. That will also improve the soil characteristics in terms of holding moisture. We also have anaerobic composting. So this anaerobic composting generally we perform when you have to manage certain waste which we cannot manage with aerobic composting. And this anaerobic composting will also gives us the methane that can be properly tapped, cleaned, can be used as a source of energy. End products remain same. Raw materials are slightly different what I put for anaerobic composting. Now this table shows me the typical comparison between aerobic and anaerobic composting. The aerobic composting, which is also called as hot composting. Anaerobic composting, we call it to be cool composting. Aerobic composting, there are no rules, regulations. When compared to anaerobic, aerobic can be on any flat ground, which is free from waterlogging facility, which is slightly elevated, having the penetration of good air, proper soil drainage should be there. Then we can go for aerobic composting. For anaerobic, which is also called as pit composting, we need to have a pit dig into the ground or a reactor which will not allow air penetration. Aerobic composting requires oxygen, whereas anaerobic composting doesn't require oxygen. In case of aerobic composting, we need to turn for every 2 to 3 days based on the requirement. Aerobic composting can be it can be any size. There is no restriction. Anaerobic composting, of course, for decentralized, centralized, you have their different sizes for that. Aerobic composting is much faster because we are supplying oxygen, so degradation rates are much faster. Anaerobic composting is very slow. Aerobic composting needs smaller space because its retention time is small. Whereas anaerobic composting retention time is much higher, so you require more larger spaces. Now, having understood what is composting, how do we execute it? What are the different benefits we get from the composting facility? Now, if you want to really plan a composting technology, and so far, maybe if you look at it technically, it is something like waste generated at one point or different, say waste generated by the community. It's simply collection, transportation, managing. Seems to be very simple for you. But as some people has mentioned, in some countries it was successful. In our country, it is not successful. At some places, the reasons, if you want to really analyze, then we need to have a comprehensive view of the entire process. So if I divide my issues into economical, political, legal, social, environmental, and technical aspects, then if you look at it sub aspects, this particular table shows me what are the points I need to thought of or I need to keep in my mind before planning a composting technology, what type of technology, what scale I have to plan, and how do I execute it. So, as per the plan, the first thing what I need to know is, I need to identify what are the interests of the stakeholders. Who are the stakeholders? The stakeholders are nothing but the population of the city and as well as the workers involved in the process and the engineers who are at administration level, what exactly they wanted. And their willingness to accept and participate in an improvement of the program completely from waste collection to finally composting and finally delivering the composted product to the end users. And we also need to get the sound data from the beginning, which will help to develop appropriate partnership at the very beginning itself, rather than having a difference of opinion at the end. This will bridge the gap between your planning and implementation. And there are different models available which can be used for successful implementation of this composting. You can have resources from public sector, private sector, and non-governmentals. Now, who will take active part? Whose responsibility is what? That depends on the stakeholders' interest, who are the funding agency, what type of model they are implementing, like government authorities, municipal authorities, whom we can call to be public sector, and private sector, you have a lot of companies who are into, for example, India we have, this some companies like Ramki, L&T, and coming to non-governmental companies, something like even households at decentralized at household level itself, they can do the composting. Okay, of course, there are some 10 main questions which are there for implementation of composting. We need to answer. So before planning any facility, we need to answer for the 10 questions. The first question happens to be, does a primary house-to-house collection exist in the municipality? That is the first question. how do we collect the waste? Do you have a formal collection system, or people have to, take their waste and give to put in a dustbin, common community dustbin? Are they involved in source segregation? What type of support? Who is the funding? Whether any land available for composting site? Particularly in case of centralized composting, how do we carry the waste from source of, from point of generation to the terminal management point? How these roads are connected? If the roads are good, are the people aware of waste mismanagement? Waste mismanagement in the sense, not that somebody will theft your waste. We can see frequently in urban areas people to be burning the waste, vapor burning. If people burns, it's one issue. And see, sometimes the person who is supposed to, collect the waste, that person himself is, sometimes they fire the waste, they burn the waste. That is more dangerous. Having known about the dangerous effects of burning the waste, they involve all these things. And what type of knowledge the stakeholders on how do we implement the composting technology? So what is a composting experience? Like any trained persons are there for this composting or not? And what is the demand for this compost? And if we have this data for all these questions, then we can say that will form a basis to plan our composting facility. And sometimes to answer these questions, we may have to organize different community meetings. We need to conduct structured surveys using a questionnaire. And we may have to make field visits to check the land availability and shortlist the sites. That will sometimes help us how to approach and inform the community. And we can also evaluate the willingness of the community to participate in the project. And we can also get some ideas and concerns of the beneficiaries, something like if the waste facility, if there are any problems in waste collection or problems in the compost quality, how do we go about it? And what about the community willingness to cooperate and to what extent? So this is a typical questionnaire which can be used for a community survey. Like, are you satisfied with the current system? And does the municipal administration provide a solid waste management service in our area? Sometimes these questionnaires will help not only the survey person to understand the scenario, sometimes these questionnaires also ignites thoughts or create awareness among the public to think differently in order to help the administration for the effective implementation of these policies. So what improvements of waste collection system would like to see that is applied? If your waste is collected directly from your house, how it should be collected? These are some of the questions. So this will help getting the data required. And maybe we can use some of these equations to collect sufficient data something like what is the quantity of solid waste that is being generated and its quality, like physical characterization, chemical characterization. As Professor Chandrasekhar mentioned a few minutes back in his presentation, the physical characterization gives you moisture content, density, and the fraction of organic to inorganic and so on. The chemical composition tells you the ultimate analysis like CHNS. And if you ask me the question, sir, is it possible to go for elemental analysis for all the people, for all waste handling facilities? Yes, may not be possible for all waste management facilities to have an elemental analyzer. So, but the good thing, most of the waste which are available in area, already there approximately carbon to nitrogen ratio is almost all known for different types of waste which are being collected. If we are able to quantify their sub-fraction, we can assess what could be the composite quality of the waste. This will give us, as I mentioned earlier, green and as well as brown, what is the nitrogen, what is the carbon. This will give us some of the thumb rules. This thumb rule will help us basically to mix the proper carbon to nitrogen ratio, what proportion we have to mix them. Not only that thing, not only waste collection, we need to look at it, the possible sites. If you ask me the question, sir, how do we locate site for composting facility? Well, strictly speaking, if you ask anybody, we want to set up a composting facility at any point of time, at anywhere in the city, the neighboring people will always oppose. Because they may not have enough confidence on the authorities that they will definitely able to maintain the process as they thought of. That is about social angle and political angle. And from engineering point of view, there are certain points which we need to keep in our mind, like what type of topography, whether vehicles can reach, roads are there. By considering these points, we can collect, we can identify the site. So once we identify the site, then the next thing is we need to prepare a business plan, like who will operate. Is it owned by municipality and operated by municipality, or owned by municipality or community will operate, or completely privately owned, like a complete outsourcing of the entire activity? And as I mentioned earlier, the different scales of waste composting models. If it is facility is more than 11 ton per day, we call it as large scale. Medium scale 3 to 10 tons, small scale 3 tons per day. And the households which we get it, in a family of 4, we may generate approximately 1 to 1.5 kilos per day of putrescible matter. That can be very small scale, that can be called to be decentralized, or household bins. You can see these two figures, which we can use for household and as well as rural areas for a mix of 2-3 houses. The left hand side system shows you the box composting, whereas the right hand side shows you bin composting. The composting bin. The holes will facilitate the proper supply of oxygen to the composting material. You can see how a person who is operating the bin need not have the complete knowledge of the technical knowledge of the entire operating process. But the system, the engineered system shall able to help even the illiterates to use the system. And sometimes to have this type of technical equipment will make us to study the systems better for its implementation.
Sir, one question.
Yeah, please.
Sir, when we are composting the organic or inorganic materials, so at that time we are taking into consideration that the moisture content is better or not, and the aerobic and all this. But do we consider the sunlight? Like without sunlight, can it be compost or not? Is it important or not?
Yeah, surely I'll answer your question. Just give me another 10 minutes. Let me complete my lecture. Then I'll keep the floor open for discussion. So that time I'll answer your question. Okay. I'll discuss.
Okay, no issues.
I'll discuss
Thank
that
you.
point as well. Okay. Sunlight also. I'll
Okay, sir.
okay.
Fine.
So for its effective implementation of composting process, we need to follow a structured path. Like we need to have proper steps, proper collection, sorting, piling, composting, and maturing of the composting. And once compost is matured, the maturing means basically the degree of readiness. Once it is ready, then we need to have proper screening, remove the unwanted materials, okay, or remove the undigested particles if at all present, okay, unwanted materials, something is there, just screen them out. And because see, any commercial viability of the product depends on its quality. So to improve the quality, we need to do certain screening procedure, and then finally bagging, and then finally selling. Okay, these three activities we call them to be marketing. So this is what a box composter, which is being implemented in a plant, is being shown here. This particular figure shows you, this is what we call it as screening. Okay, we screen them. So this is what we call it to be a centralized composting facility. How the wastes are being generated, no, they are getting to the site, how they are being unloaded, and they are mixing up different wastes and making a pile. And sometimes we may also use the leachate generated from the composting to improve the moisture, because this leachate not only will enrich the moisture content, it will also supply the active microorganisms. And we may also look at it, the temperature control. And we may also have to monitor the oxygen levels. If the oxygen levels are completely low, then we may have to, use forced dryers, forced blowers to supply external oxygen. Something like this. And once we get the compost, then we will check its readiness, whether it is matured or not. And once it is matured, then we do screening, and finally we do packing and selling. And approximately 1 ton of organic waste will give us approximately a quarter ton of composted harvest. 3/4 material is lost, is digested. Lost, some of the moisture will lose. Something will be screened out. Something will go as into landfilling. Altogether, we get approximately, this is a rough formula. And with reference to this windrow composting, there is a separate session on the composting technologies that will be handled by Professor Hariprasad Reddy subsequently. Then he will talk about all these points. So this is what we call it as windrow, as it is simply available. I am just showing it to you. I can also show you how the turning takes place with the help of a machine. Are you able to see the video?
Yes, sir, clear.
So this is called as anaerobic method, which is also called as Bangalore method. What happens is we dig a pit, put the material in that. Basically, when we have this night soil and refuse, then we go for this Bangalore method. Make a pit, fill the material, cover it with the top soil, leave it for almost 6 months. Then we get composting. And another thing which we have seen in our decentralized composting is vermicomposting. So we use the natural worms, red earth worms, night crawler, perionyx excavators. These are the different types of earthworms which are available. Use them for generating a better quality of composting. We have, once again, in vermicomposting, we have small scale vermicomposting, large scale vermicomposting. And vermicomposting, we have bed method and pit method. This is called as bed method. This is called as pit method. So here also, particularly as we are growing worms, we have to be extremely careful about the moisture content. And particularly normal composting to vermicomposting, the only difference is normal composting, the process can be having little variations. The quality of composting, there can be some variation. But in case of vermicomposting, if the variations are beyond the tolerance limit of these worms will die. And it takes a lot of time to regenerate the worms. And you cannot allow it to increase the temperature like 60-70 degrees centigrade in case of vermicomposting. The pile has to be very small. So even the operating philosophy principles more or less same, but the actual field conditions will be different. So this is how the vermicomposting pit, the specifications, how you should fill pit with each material. And of course, vermicomposting, there are certain problems, something like dying of worms. So that could be problem is not having enough food, so we can provide proper food. And it may be too hot, so to provide proper shade and proper sprinkling of water. Sometimes we may get bad smell, then you need to provide proper air circulation. So by maintaining these conditions, we can preserve the worms as well. So these are the basic C/N ratios for different materials. For green and brown materials, as I mentioned earlier, accordingly we can choose to get the optimum ratio. The best thing would be around 30:1, the carbon to nitrogen ratio for optimum mix. Accordingly, you can see which material you have to use. So this particular table shows you the comparison of composting technologies. This may be explained by Professor Hariprasad Reddy, so let there not be any duplication. So these are the compost quality standards. Maybe Professor will be talking about this also a little later. We have lectures scheduled for this topic also. So I don't want to duplicate the things. But now let me tell what are the constraints which are faced by the composting sector in India. The biggest problem is getting a good quality of waste to the facility, and sometimes lack of knowledge and practical experience. The trained operators, if they get some good job, they leave the facility. And there is definitely some cost involved in bagging and transport and marketing, that sometimes making the product to be almost all costly. than compared to the synthetic fertilizers. So there shall be subsidy given by the municipality authorities or the governments for promoting this compost. So these are some of the problems or constraints faced by the composting sector in India. So this is from my side. Now the floor is open for discussion. Yes, let me see the questions.
Hello, sir.
Yeah, please.
Okay. So
Please,
I
please.
was asking that whenever we are composting organic and inorganic materials, so at that time we take some factors into consideration like temperature level, moisture level, oxygen level, and turning the pile time to time. So also I want to ask that sunlight is necessary for composting or not? Like supplying sunlight, is that important?
Sunlight definitely an influencing factor in the effective implementation of composting, no doubt about it. But the problem is,
But sir,
let me answer your question here. After answering, then you can ask me
okay.
ask further clarification. See, sunlight is definitely a factor, and having good temperature will elevate the composting process acceleration also. But more than sunlight, the problem is that should be protected in case of rains. Okay, so
Right.
the composting temperature, say once you put the pile, automatically it will raise to the temperature of 60 to 70. So whether sunlight is there or even night times also we can check the temperature. The temperature will be attained naturally by the microorganisms, particularly aerobic composting. If the sunlight
Okay,
is
so
there, if the sunlight happen to be there, loss of temperature will be less. Maybe turning frequency can be increased.
Exactly, yes.
If the some question is there, somebody is asking, composting yard, if the heat is not generated sometimes, what might be the reason? So there are two reasons. One thing is the probable absence of the required putrescible matter or organisms may not present, or the probable developing of anaerobic conditions. So these three could be, or if you don't have sufficient moisture content, then also you may have. So these are the multiple factors which will influence for not having sufficient temperature in the composting process. Yeah, oxygen is necessary for aerobic composting. Approximately, we wanted above 6 ppm to get a better aerobic composting. If the oxygen levels falls below 5 ppm, then that will lead to anaerobic composting. So we need to ensure that the oxygen levels are above 6 to 8, favorable. Strictly speaking, aerobic composting is much economical. It has more ruggedness, less orders, easily implementable, practical implementable. Yes. Any more questions?
Hello, sir.
Please.
So in aerobic composting, you spoke about the raw materials. In the slide that you showed, it showed the raw materials to be organic matter, inorganic nutrients, water, and microorganisms. So what exactly do we add? I mean, you collect all the organic materials, you put it in a bin. So I'm speaking about decentralized, that is a smaller version, household version. So I just compile all the organic matter, I dump into the bin. So by default, microorganisms are already present. Do I need to add water onto it? And what is that inorganic nutrients that you actually have mentioned?
See, strictly speaking, there are so many micronutrients in addition to nitrogen and other elements, because these are naturally present in the waste which we are adding. You need not add them separately.
Okay.
Only proper care you have to take is you take a right composition of green and brown such that you will get a a end carbon to nitrogen ratio of 1:30. 30:1.
Okay.
So if you're having that much, see, if the ratio is close to that, which is made from the locally available material, then obviously you will have a good, sufficient optimum proportion of the mix, which can take the composting process to take place.
No, okay. Sir, I've been doing this composting in the residential level in my house. Actually, I buy a compost brick. What I do is I put the organic material into the bin, then one layer of that compost brick, and again I keep filling it and I keep it there, keep that aside for 3 weeks, and it then gets completed as a compost. So what exactly goes in that compost brick that I buy?
That is nothing but brown. We are getting sufficient grains produced at our house.
Okay.
So the brown will ensure that the proper nitrogen is given, and as well as that is being porous, which will also ensure that the proper supply of oxygen.
Oh, okay. So you mean to say if I try mixing equal amount of brown and greens, I wouldn't require that extra whatever brick I'm getting. So it will get.
Yes.
Okay.
Yes.
I would definitely would want to try. So thank you.
Please. Any more questions? Somebody was asking, we have conventional composting and mechanical composting. Which method is best? See, it depends on, as I told you, the composting process has a lot of variables. So what level you are doing, what is the machinery, what is your objective, accordingly we can decide what is best. We cannot directly tell which is best. Any other questions? Okay, if there are no questions, I thank you all for your patient listening and asking for these questions, and thanks for your interaction. Okay. Next session. Yes, please. Yeah, the next sessions are the next talk. The details will be shared to you by organizer Professor Chandrasekhar. Thank you all. This is from my side.
Yeah, thank you.
Thank you, sir.
Thank you, sir.